Hello, everyone. I'm very much excited to share a solution that can auto-heal your networks using NSO. Let's look at what's there in the agenda. We're going to look at how typical operations teams are resolving issues in a day-to-day basis, and how we can automate it using the auto-heal solution that we're presenting in today. We'll go through the solution components, and we're going to have a quick demo of it. We'll also look at the pillars and approach for a successful automation journey, followed by benefits and use cases of auto healing. In a typical service delivery environment, the customers, our partners are providing different kinds of services. We've taken an example just to show you how the service environment look like and what are the different kinds of components involved in there. So we have taken infotainment service as an example. That could have dependency on other services like BSS or analytics in order to give a proper experience to the users. Each service in turn will have different layers within them, like an application layer, a middleware layer, or a database layer, and also the network as a service so that it can talk to the other services to get what they wanted, right? So similarly, the other services also will have its own set of layers, which will in turn provide the responses that are required by the other services. Now, we are going to take a look at the scenario where one of the one of the interface to which the service is connected. The services could be on a container, or it could be on a VM, or it could be on a physical host as well. So that's getting connected to the network layer. So the interface goes down here, and how the team goes about solving that particular issue. So once it goes down, you can see that the interface is down, and the users start seeing the issues in the service that they're consuming. So they have started raising multiple cases, multiple phone calls, and immediately the teams that are responsible for resolving the issues are jumping into a crisis call. And what do you think would be the first thing they'll be doing is this, right? Most of you would have experienced this at some point in your tenure of the automation world, or I would say the operation world. So everybody would start saying, I mean, every team would be saying, it's not our fault, it's some other team's fault, right? So since it's a critical service, some cost associated to the downtime of the service, definitely there'll be a crisis call, and then crisis manager understands the situation, and then he takes it, and then he kind of hits on all of the teams and make them work together like this, right? So typically, this situation occurs at all the customer environments, and this is just a kind of explanation on how does it look like. Fun apart, this is the kind of a flow, very high-level flow, using which each team kind of tries to sort out or troubleshoot the issues within their area. So they start with some initial checks, then they start identifying the issue category. The issue category could be something like some issue with respect to memory or CPU or storage or hardware. These could be common across all the other applications like network, apps, storage, and databases, right? If you look at the network, there could be specific categories such as bandwidth issues or access list issues. Something happened and the access list ends, the service is down, or something interface related issue, the interface is up or down, so some looping problem, or the link is down, right? So similarly, with respect to storage, we have the issues like the categories like disk related issues, LUN related issues, and so on for the other categories also. So we have listed down kind of few examples with respect to each of the layer, just for demonstration purposes, but like the list is not exhaustive. Then they start identifying, once the category is identified, then they look at what exactly is the problem. Is the CPU crossed the threshold, or the memory is completely consumed, or there is no space left out in the storage, or the interface is up or down, or access list is not having not providing the enough access, right? Like which they are going to determine what exactly is the issue type with respect to each of these application layers. Again, these are just for examples, but this list is not exhaustive. This is just for understanding purposes only. Once they identify the issue category and also the type of issue, they look at the knowledge base, what they have. It could be in the form of SharePoint or a Confluence pages where all the past issues have been issues and corresponding resolution have been saved, or it would be in some team's mind. So, however, the team is going to look at all the possible avenues, and then they're looking to kind of identify whether there was an issue which is similar to the current issue, and if it is, then they're going to look at what is a possible solution. Once they identify the solution, they will move on for applying that solution to that particular environment, and then they kind of validate whether the issue have actually solved, whether the solution has actually solved the issue or not. That's the next step. Once they validate, they also verify with the customers whether the service is back up online, so that we get some good responses from the customers. Also, it gives a better experience. The sooner the problems can all be avoided, but how soon we can solve the problem gives a better experience to the customers. So once verification is done with the customers, then we are going to close the case. Now, this is the manual process, a very, very high level process, how a team goes about solving a particular issue, right? So now what we're going to do is how we can automate this process using NSO and open source monitoring tool is what this session is aimed at. The problems can be classified into two types, the known problems and unknown problems. Known problems are the one that we have faced it in the past, and we also know some solutions to some of the problems, and for some problems we may not know the solution. Maybe we are still working with the respective vendors to get that fixed. And the second category is the unknown problem, which is we have not seen it in the past, but we have to do some research in order to identify what exactly went wrong, and probably we may need to kind of get the solution and document it. Now, what we are going to look at in automating using the auto heal is this particular hierarchy. So we are going to look at automating the known problems that has known solutions. So by this way, we are going to give some time back to the engineers who can concentrate on the unknown solution as well as the unknown category of problems. These are the solution components that make up the auto heal. There are two important components. The first one is the network services orchestrator that is used for orchestrating the network devices in terms of managing them and making sure all the configurations are intact. The second one is the NAGIOS, which is used for monitoring the environment. It monitors the network devices as well as the other infra components, and then it is going to kind of trigger the alerts or notifications to the network services orchestrator that in turn can actually take care of pushing the solutions. The third item that we have is a Nexus device that we are actually using it for today's demo. We are going to simulate the same issue where the interface is going down, and how NAGIOS kind of sends out an alert to NSO, and then NSO in turn solves that particular issue is what aimed for today's demo. Within network services orchestrator, we have these four important components. The first one is the event log history, which is used for capturing all the events that are being reported by the NAGIOS. That kind of tracks all the events that are reported back. so that we can get to know whether the network services orchestrator was able to solve it or not able to solve it, right? So in case if the solution is applied and it is working properly, then no problem at all. But in case if the solution is not working, then somebody has to look into it. So even clock history plays a major role in tracking the status of each and every event and then taking it to the closure. Second one is the device group mapper that is used for kind of mapping what all devices can be auto heal using this solution, so that we are not touching the other devices, so that we can avoid unknown disastrous situations occurring, and then we don't have to worry about it, right? The third one is the knowledge base intent identifier. This is used for identifying what knowledge base, basically the problem category and problem type. So using the event information, it's going to fetch what category it is and then also event type. Using that, it is going to use the next table, knowledge-based definition, to actually identify what solution that it has to apply. So basically, event occurs, and then we want to look whether that particular device for which the event occurred is are we healing using this solution? If yes, then we go and check what kind of category and what kind of event it is. If it's, for example, interface is the event category, so event could be like up or down, right? So using that, we go to the knowledge-based definitions, and then we kind of determine the corresponding template that needs to be applied. So this is the solution architecture. So we're having a set of networking devices that are being monitored. So not just networking devices, it could be any infra element that can be monitored by the Nagios. Nagios is the monitoring tool which kind of monitors these devices using the SNMP. And we also have NSO that has the knowledge base and also the solution which it can use for solving the problems. Let's take an example how the process flow happens here in an automated way. Once the interface is down, Nagios will get to know that the interface is down, and then it will perform two more checks before notifying NSO that the interface is down. That's because that's the basic correlation that it does, so that it's not giving false positive alarms. So now it checked for 3 times and it found that the interface is still down, and it decides to send out a notification to NSO, hey, this particular interface is down. So NSO, upon receiving this notification, it first checks, as we discussed in the last slide, first check whether that particular device is being managed by AutoHeal solution. If it's being managed, then it looks at what is the event category and also what is the event category type. It determines that, and using that, it determines what solution it can apply to the device that sent out an event, so that it will come back to normal, right? So in this case, it is going to figure out what template it has to apply using the details that are sent by Nagios. Then it's trying to apply that template, and you can see that the interface is back up online, so it looks green. So this is where it looks green, and then Nagios immediately gets to know that the device is back online after some time, right? And immediately it lets NSO know that the service is back up, and NSO in turn will now record that status that the particular template that was applied actually resolved the issue, so that we can keep track of the templates that's actually resolving the issues, that it will be useful for the other upcoming events. Let's get on to the actual demo.
Before starting the demo, let me show you the components used. The first one is the terminal for Nexus 9K console. We're going to shut down one of the interfaces and show you how the AutoHeal solution is going to bring it back online without any human intervention. On the right side is the WebEx collaboration platform we have a WebEx bot integrated to AutoHeal solution that is going to kind of notify the users what's exactly is happening in the backend of the AutoHealing process. The next component is the Nagios, which is monitoring the Nexus 9K device. We are basically monitoring the two interfaces, 1/1 and 1/2. Right now, both of them seems to be okay. In case if there is a change in status, I mean the state of the interface, then it is going to notify NSO after performing basic correlation. It uses SNMP protocol for monitoring these interfaces. The next component is the NSO, which is the critical player in the complete solution. We have developed a demonstration package called as AutoHeal that has two components, lookup data and actions. Actions has the set of actions which are used for processing the events that Nagios is sending out based on the issues that it is seeing. Lookup data, we discussed the same thing in the solution components. Entry criteria is the one which allows the user to define which device groups are allowed to participate in the AutoHeal solutions. Once the device is verified that it is part of one of these AutoHeal groups, then the next step is to identify the kind of category of the event. So in our case, we are dealing with the network interfaces. So I have defined an interface category, and these are the keywords which will be matched to kind of filter down to this interface category. The events coming from different kind of layers, be it a network layer or a database layer, the details or the type of events will be a little different. So hence we are using these keywords to kind of filter and then exactly identify what kind of category it is. Basically, we are using these keywords to categorize the event. And the next table is the place where we are defining the actual solutions for a particular category of event and particular state of event. What is the solution that NSO should use? So in our demo, we are shutting down an interface. So we expect NSO to kind of detect that and then bring the solution with the interface back online. So we are using interface as a type, means category, and then status down. Once NSO sees that in the event details, then it's going to use this template to kind of bring the interface back online. It's not just the templates that can be used with this solution. We can also execute set of commands in a particular order to solve that issue. The next important table is the event history. Uh, any notifications from the Nagios will get logged here, and also uh, the status of auto healing is also getting captured, so that in the future we can actually get to know what all events got solved by this auto heal solution and what all solutions for which Nagios, I mean the NSO is not able to solve it. So we can kind of filter it and then keep improving that. So let me go ahead and shut the interface. Before doing that, let me show you the interface status of 1 and 2. So it's 1/1 and 1/2 seems to be up. I'll show the same thing on the Nagios side also. It seems to be up here. Let me go ahead and shut that interface. And let me show the interface status once again here. So the interface is down. Let me check at the Nagios side. On the next check, it is going to identify that interface is down, and it is going to ensure it's actually performing the basic correlation, meaning it's going to perform the check two more times to make sure that the interface is down. then it is going to notify the NSO. We can see what's happening in the backend in this chat messages. We have this WebEx bot called as healer. It has sent out a note that the interface 1/1 on Nexus 9K device is down. The next message is like it found some solution in the knowledge base and it's trying to uh, apply that. So now the fix is already applied. Now it's waiting for the Nagios to let the NSO know that the interface is back up. So it's saying that the solution which it used resolved the issue, meaning that 1/1 is up now. So now I think it's the right time to go and check the status once again. Yep, the interface status of 1/1 is up now. And let me go back to the Nagios. I think it should be back again. Yep, it's back. That's it for today's demo. Thank you.
Hope the demo was interesting. Let's take a look at the important pillars of auto heal solution. The first item is the strong knowledge base. It is very much important for the solution to work properly so that it's like the brain of the solution itself. How do we go about building this? So we can start off with manual efforts. The team can start looking at the past cases and then they can identify the event categories and corresponding solutions, and then they can build templates. The second thing to automate this particular piece, we can also look at machine learning. We can provide the past case histories to the machine learning algorithms where it can identify the corresponding problems and corresponding solutions. The important thing to keep in mind is that whenever we are building such things, the corresponding solutions should always be machine understandable fixes so that even humans as well as the machines can use that and fix a particular problem. So it can start as a hybrid model where if the solution cannot solve the problem, then the experts can pick it up and then solve it. And gradually, over the period of time, the machine itself can pick it up and then solve it with a higher percentage of accuracy. The second important point is that fully mapped configuration management database is essential so that we can map out the corresponding dependencies and then we can easily figure out and correlate where exactly the problem is. In the example that we showcased, initially the manual example, right, the interface went down, but the each and every layer would be showing alerts in the monitoring tool that the database is down, the service is down, the middleware is down because the network connectivity itself is not there, right? But how do we know where exactly the problem is there, problem is lying? So CMDB plays a major role. If we have a properly mapped CMD for each and every service, corresponding components and corresponding services that it is touching, it is easy for the solutions, the algorithms to detect the problems, and then basically it can perform the situation analysis. It can pinpoint it, and then it can easily identify the corresponding problem categories and the types. The next important thing is the technologies and process. We'll have to be very conscious about choosing what configuration management tools that we are using. For example, NSO can support multi-vendor devices. So using which I can automate any of the configuration changes on any of the devices that my network has, right? But in case if it's supporting only specific to a particular vendor, then I'll have to look at different configuration management tools for different vendors that my network is composed of. So always look at the tools which can support different, or I would say hybrid vendor support. Right. The next important tool set is the monitoring and correlation engine, because this is very much essential for kind of identifying the issues and then also After identifying the issue, then it can correlate, and then it can remove the false positive, and then kind of notify back to the orchestrators like NSO so that it can actually give the solution. If you're not doing the correlation, then there'll be a lot of false positives, and there'll be a lot of issues that it may create rather than solving problems. The next important item is the process standardization. This is very crucial for any automation to work. Because in case if the solution is not able to solve, means automobile solution is not able to solve a particular problem, then there has to be a way that it can communicate back to the team, SME team, who can in turn take over it and then manage it. So whatever the kind of scenario it is, the process should have ifs and buts to kind of take it to closure properly. I mean, the last one is the effective handover. Not all the solution, means not all the problems can be solved by this solution, right? So there has to be an expert who can kind of guide the solution, meaning the automobile solution, for some time, and then also kind of take it over in case if the solution is not able to solve. Not all problems can be solved. So the category that we picked up is the known problems and that are having known solutions. That's what we are actually aiming to automate. For the other categories, we still need people to kind of spend their brains and then identify the issues and sort it out. The first benefit is the no human intervention. That's best automation anyone can achieve. If there is no human involved in any of the processes, of course, it improves the MTTR, mean time to resolve any issues. It also in turn increases the customer satisfaction. So below are a couple of other use cases what you can additionally implement, but this is not the exhaustive list. Each and every infra element that we talked about in the initial manual process, we can automate a lot of things using this automobile solution. So be it adding a link to an Ether channel or dynamically scaling the VNF based on the CPU and memory usage. In case if the CPU is very high for a particular VNF, we can automatically spin up a new VNF and then route the traffic, change the traffic, and change the route, and then to point to a van which has a good amount of capacity over the night, or based on the load, or automatically switch between active and standby, or restarting any of the services on the core switches and routers when some certain conditions are met, or performing some automatic checks and then kind of giving the results of those checks to the SMEs, who can in turn start with that particular results. Basically, it can give a pointers that these are all things that I've checked and these are the results, and from there the SMEs can start on rather than starting from the scratch. So this is a kind of a strategy for successful journey in the auto heal solution that can be implemented. First thing to do is that where to start, right? The first question obviously comes here is the where to start. So the first thing to do is the assessment, where you'll have to look at your environment and pick one service at a time, and then analyze the past issues that occurred. It could be issues or a problem, and then capture the relevant details, like how frequently it occurred, how much time it took for resolving that particular issue, what was the criticality, what was there a kind of a business loss, or what was the severity of it, how much impact it made, right? So capture all those details. So first capture all the issues, and then correspondingly capture all the relevant parameters, then perform the ROI analysis. So using these the use case, for each of the use case, first look at how much time it would require for automating that particular issue or a problem. And then determine how much approximately, right? So we cannot give the actual numbers, at least we can approximately come up with how much time it can save, right? Then we can also map the other parameters like the business priority and all that. Using this data for each of the issues, or I would say it's a use case now, for each of the use case, come up with these numbers. which will kind of help us in determining how much savings that we can get by automating that particular use case, be it a number, be it a cost, or it could be an intangible benefit, right? So we can come up with that number and we can sort out based on the return that each of the use cases is giving up, take the top 10 use case and then start automating, right? So that's the approach that we have to take so that we are not spending our efforts in automating something which is not going to give us returns. So the most of the automation teams, the mistake that they do is like they pick anything, then they start automating. They don't realize that how much return that it is going to give. Is it worth investing in automation? That's the first thing that we have to do. So unfortunately, none of the teams does that kind of analysis, so that like after the effort is spent, it is very difficult to convince the leadership that this is kind of giving some kind of savings. So without an ROI analysis, it's going to be a problem at the end. The next important item is the design framework. Is that I mean, you have to design the framework for your solution to work, right? So it has to be a scalable, and it can also work for the future. So meaning the technologies are changing every year. So the solution, what we design, should be capable enough to kind of support in the future enhancement technology stacks also. Once we have the framework in place, then we can start automating the solution. By framework, I mean that like we need to have a proper configuration management tool, like a NSO as an orchestration tool to manage the devices, and we need to have a proper monitoring tools, and we need to have a proper correlation engines so that like we are set to start automating things into our environment. The next item is the automate. So this is based on the priority that we have picked up, based on the ROI that we picked up in the last stage. You can start picking up each of the use case, and you can align your teams and then start automating them one by one. The important point to note here at this stage is that we can automate and we can deploy, but what we missed to do is like tracking the numbers, like what was forecasted before and how much is that after implementation. So we'll have to track it so that we can kind of constantly check whether are we on are we nearing to the forecast, or are we are overburning the forecast, or are we spending too much? Because that's essential, so that in case if it's we are investing so much of time when compared to the returns, definitely that can be scrapped. Otherwise, if you're not doing that, it's going to be a burn down on the cost or the budget that we have for the automation. The next piece is the continuous improvement. Not any solutions can provide support or will work forever, right? So once a solution is implemented, it cannot work forever. So it has to kind of go through evolution as and when the technology is getting changed. So every year there are new updates coming up, new platforms coming up, new solutions coming up. So, and we keep kind of transforming based on the business needs. So even the automation has to evolve as well. So we'll have to continually improve. And the next thing to do is like once one service is completely automated, then pick up the next service and follow the same cycle once again. If you have more questions or you want to know more, you can drop a note to my email ID. So it's here, esramasa@cisco.com. Or you can also pick up your mobile and scan this QR code and provide your feedback. You can also type in this URL onto your browser, http://cs.co/autoheal to provide your valuable feedback. Hope the session was interesting. I'm glad to be part of this NSO Developer Days. Thank you so much.